Hi, and welcome to our chemistry video for the day. We're on section 2.2, elements and compounds. And to start with, we are going to look at a little illustration or analogy here. We're going to look at how words in a book would be similar to matter and the way matter is put together. So if you'll just bear with me a minute, you know that we have 26 letters in the alphabet, and if we take a few of those letters, say A, D, and M, we can look at them and we can create several different words with those. Down here are some examples, and I'm sure you can think of a few more. And those are words that when we put those letters together, we can create the word. So in a similar way, we have many different atoms, actually, to be exact, since two different atoms were recently discovered, we have about 118 different elements. So there are at least 120 different kinds of atoms that could be put together. Only 94 of those are naturally occurring. But if we have that many different kinds of atoms, and we just take a few of them, we can put those few together to create something that we call compounds or molecules. So let's look at how that looks. Atoms are the tiny particles that cannot be broken down any further. Here are some examples. Here's hydrogen, oxygen, and carbon, examples of atoms. And if we put those together, just like we can create words from different letters of the alphabet, we can create compounds from these. Here's a compound, carbon monoxide, has a carbon and an oxygen. Here's hydrogen peroxide. It has two oxygens and two hydrogens that are bonded together. Here's a water molecule. We have oxygen being represented by the blue circle and hydrogens being represented by the yellow circles. And then here we have a carbon, right here, carbon, and two oxygens, carbon dioxide. So those are just some different examples. There are just many different compounds all around us all the time. Here are just a few examples of some compounds that we can make with just these three different atoms. Now, I would like to make sure you understand the difference between compounds and molecules, just so you can be using these words appropriately. We just looked at some different compounds. Compounds always have two or more different types of atoms that are bonded together. They always have the same composition, meaning that here we have a hydrogen peroxide compound being represented. It has two oxygens bonded like that and two hydrogens on each end of those oxygens. If we were to have another hydrogen peroxide compound, it would look just like that. It would have the same composition. So that's what that means there. Now, what is a molecule then? We know what a compound is. What's a molecule, and why are those used differently sometimes? A molecule can be just the same thing as a compound, such as this. This is a water molecule. We have oxygen with two hydrogens, but a molecule can also include atoms that are the same bonded together. So here we have two oxygens bonded together. We call that diatomic oxygen. It actually likes to travel around like that, two stuck together. So we would not call this a compound because they are the same, two of the same atom bonded together. We have to call that a molecule. But we can call both this and this either a compound or a molecule. The hydrogen peroxide or the water could be either. So just to be clear, compounds always have two or more different types of atoms. Molecules can have two or more atoms bonded together. They can be the same. So then what is an element? Elemental substances contain only one type of atom. So here, I just give an example of the atom carbon. We can see in some different forms, and it's kind of an interesting one because right here is a structure and it's showing some different carbon atoms. They're all bonded together in such a way that this is what they look like to the eye, a diamond. Okay, carbon atoms may also bond in this way. These here individually, if you can see those, the little tiny circles in there are the carbon atoms, and they layer in these sheets as well. And what they look like to your eye, when you can see enough of them all together, is graphite. They look very different, but they are both made of elemental carbon. So when we talk about the elements, we're talking about all those different elements. As you remember the periodic table that's probably over there on the wall or in the back of your book, you see all those different elements. Those are all different kinds of atoms. But what's important about an element is that it contains only one type of atom. So here, this is elemental carbon, and this is elemental carbon because all the atoms in there are carbon. Okay, here is a quick review. If we just look at these drawings, helps us to look at what we've been talking about. Right here, it's a representation of atoms. Remember, atoms are the smallest particle. It can't be divided down further. And each of these represent an atom. Here, these are molecules. They are two of the same kind of atom bonded or joined together, and they make molecules. Both the atoms and these molecules are elemental. They have the same type of atom represented here in this group and here in this group and bonded together. It's the same kind of element. And here we're talking about compounds. Remember, we have two or more different kinds of atoms that are joined together into a molecule, and we can call that now a compound because there are two or more different types of atoms present in that molecule. So are you interested in achieving a proficiency of 4? Here are just some ideas. Research a question pertaining to elements. What are the most prevalent elements in the human body, in the atmosphere? Why? Actually, another one, look up some the recently discovered elements and what are some of their characteristics and their properties. They don't last very long, so maybe you can find out a little more about those and tell us about them. What important characteristic distinguishes one element from another? What other atomic differences are there between elements? You could compare and contrast compounds that are atomically similar, and how are their properties similar and different? Other great ideas that you may have. I don't know, come up with some good questions and look into that, go above and beyond and get a proficiency of 4. Thanks.